Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll continue describing how we partition variability for the multiple regression model. So we just finished talking about score decomposition of the regression model and what the actual score for Y is made up of. And I showed you that it was made up of the grand mean plus the systematic influence of all of the independent variables, which was the difference between the predicted scores and the grand mean, and then some leftover error or leftover variability, which is the observed score minus the predicted score. So these are actually reflected in the full model sums of squares that we get in the ANOVA table from the SPSS output. So the sums of squares regression is essentially the squared distance, the total squared distance from the mean to the regression surface. It's the sum of all of those. The sum of squared residuals is the distance from any given score to the regression surface. And it's the sum of these squared scores. So those are essentially represented in these sums of squares. The sums of squares regression is representing the systematic influence of all of the predictors included. In our smoking example, we have 2 predictors. And the sum of squares residual is giving us information on the leftover error or the leftover variability. So the sources of variability are from essentially the model that we specify, that's the regression surface that gives us the predicted values of Y, and then the leftover error. And so we have values that are assigned to the systematic influence and to the leftover error, and we get these in the SPSS output. So these are the sums of squares from our smoking example. So the total sums of squares was 378, and it can be partitioned into the sum of squares from the regression, the systematic influence, and the sum of squares residual, which is the leftover error. And here's where we can find those sums of squares in the SPSS output. I've highlighted them in these boxes. So here's how we would interpret those sums of squares. Essentially, the sum of squares regression, this value of 193.23, represents the sum total variation in smoking that's due to the entire set of predictor variables. In this example, it would be the total variation in smoking intensity that's due to years of smoking and stress. The sum of squares residual, 184.77, is the sum total variation in smoking that's not due to the predictor variables. So it's leftover error variation. Leftover variation in the scores that's not explained by any predictor variables that we included in our model. Now, the R-square effect size for the full model is the proportion of variation that's due to all of the predictor variables, the set of predictor variables we included in the model. The R-square for this example is 0.511. And so the way we would interpret this is that the predictor variables taken as a set, years of smoking and stress, account for 51.1% of the variation in smoking intensity. The R-square effect size for multiple regression we call the multiple R-square. And the multiple R-square, when we have more than one predictor included in the model, has different guidelines. It has different cutoff values than the R-square for a model that is just bivariate or just has an X and a Y. So for the multiple R-square, we consider an effect to be negligible if it is smaller than 0.02 or accounts for, the predictors account for less than 2% of the variation in the outcome. Small would be 2% to 13% of the variation accounted for. Moderate, 13 to 26%. And anything larger than 26% we consider a large multiple R-square. Now, the mean squares or the variance estimates are essentially the average influence, the average systematic influence, or the average leftover error. And those are computed in the usual way. So we divide the sum of squares by the degrees of freedom. And here's where we find those in the SPSS output. This concludes the 4th lecture on multiple regression. In the next lecture, I'll describe the first steps of null hypothesis significance testing in multiple regression with significance testing for the full model.